So photo view allows to access the Batcher function through the file feature, Batcher Plus. And as you can see, two functions are available. The first one is create Excel file. Create Excel file is the feature through which you can, starting from a limited group of photometric files like ULUMDAT, like ISLM63 or ISTM33 or OXL, you can create an Excel file, which is the base then for the second feature, which is a process Excel file. So it means that create Excel file allows you to save a lot of time in inputting the information that is then needed for the process Excel file feature. And this is done in a very simple and very fast way. Process Excel file, on the other hand, is the feature through which you can generate other files. So, for example, if you start from a limited number of original files, starting files, you can then duplicate the lines, and then you can create other files. So, for example, this is the case when you have the same photometry that is used by different luminaires. So, for example, they are different for the color, they are different for the shape. So, for example, you may have a rectangular luminaire, and the same photometry is also used by the circular luminaire. So, it is a very flexible way to manage the information through the Excel file. And so we use a lot of Excel file because there are many features through which you can be very fast in creating and adding information. But on the other hand, process Excel file is also used when, and it is, let's say, also very useful, whenever you have to generate new files. For example, when a new LED generation is coming, and so you have to update all your information. So you start from the old file, you change the flux values, and then you start process Excel file, and the new files will be automatically created. So let's start to see how Batcher Plus Create Excel File works. So whenever you select the Create Excel File, this window will appear. Through this window, you have to select and choose the source folder. So the folder where you placed the ULUMDAT files. So for example, in here, we created at this OXIC folder, we created the input folder. And in here, we have 3 ULUMDAT files and an OXL file. The ULUMDAT files are carrying only the photometry, while on the other hand, the OXL file is a file completed with the spectra information, with the images, and so on. So it means that through here, whenever we process through the other feature, which is the process Excel file, we can create OXL files, including the images, including the spectra. Why? This is not possible through LDT and IS files, IS LM63. It could be possible through the IS TM33 files format, but this is not yet supported by the Batcher Plus feature. So this is the folder, and we have to select through here, OXI, input, and confirm. And that's it. Now we pass to the second button you have at this window, which is Create Destination Excel File. We select this one, and we have to define the name Create Excel File. So we have to define the name of the Excel file we want to create, and we confirm and save. At this stage, the program will automatically start to process the LDT and OXL files, and in a few seconds, that's it. We are finished. So we go back to the folder, and create Excel file was created. We open the file, and we can see that different columns were created. Let's analyze one by one. So the first one is the column where the source Excel file, the source photometric file was headed, the description. Then there is a second column for the destination file, and we come back to this point in few seconds. Then the manufacturer, which is the first line included at the ULM.dat file. Then the measurement name, the luminary name, the measurement code, and the luminary code. As you can see, these are the four main information about the luminaries in order to recognize it. Then the source code, which is available at the line 21 of the, for example, the ULM.dat file, the CCT, the source flux read at the ULM.dat or the OXL file, the CRI, the source power, and then over here we have the total number of lamps for the luminaires. The other section, starting from the N column, is the section related to the luminary shape. So in this column, it is defined the shape of the luminary, and these are the dimensions, 3 dimensions in case it is rectangular, and 2 dimensions in case it is a circular luminary. So in case of a circular luminary, you can input here the diameter and the height, and that's it. So you place here C, you cancel these values, and you input easily the 2 values over here. The same for the luminous shape. The same set of parameters. After that, we have the X and Y column, which are not used by this feature, the Better Plus, and the Z column. The Z column is very important. It is important because in here, the program read the efficiency of the luminary and input here the value. But it is a very essential point where you can define the efficiency you want to give to the produced, to the created files. So for example, if you change the flux of your luminaires, as we said before, because you are using new LED generation, so you have to change the flux. But if you want to keep the efficiency at 100%, so you want to consider in absolute photometry, then you have to fix here the 100% value, so that the program will automatically modify the matrix in order to give at the end the same efficiency. So it means that if we change the source value because we changed the LEDs, then we have to apply the same constant, let's say, to the matrix, so that whenever we integrate the matrix, and it is done by the program, the relation in between the 2 fluxes will always carry to 100%. So in this case, we say that it should be always 100%. In this case, we say it is 50%, and this should be 39%, in this case 39%. As you could see, there were many decimals. In this case, it is done by the Excel configuration, and this is a key point. You have to be very careful whenever you manage Excel, because there are problems arising from the use of the point and the comma for the decimal values. And there are some special configuration of Excel that may bring you to errors. So be careful. Starting from the column AA, as you can see, the program added some parameters. So these are parameters that the PhotoView calculated and were registered over here, starting from the AA column. It means that in this case, we have the DLOR. The DLOR is the downward light output ratio. This one is the upward light output ratio. And as you can see, it is 0 because all the flux is emitted in the lower hemisphere. Then the UGR, the minimum value, the total source flux, the total luminar flux. In this case, you can see that the values are different for the simple reason that the efficiency, it is not 100%, like it is in this case. And then the efficacy, the ratio in between the lumen value, the luminar lumen value, and the power, and the opening angles. So these are parameters for the beam in one direction, the 0-180 direction plane, and 90 to 170 plane, so two perpendicular planes. At this stage, we have the UGR crosswise and handwise, and this is corresponding to what it is the configuration 4H, 8H, and with the reflection properties at 70%, 50%, and 20%. This is a suggested configuration made by the German Manufacturer Association in order to have a reference value, not to publish the complete matrix at the catalogs, but in any case give quite a good information about the level of glare of your luminaire. So this is what the Excel file is.